Decomposition, not just for the garden.
We're going to do a decomposition reaction. There are lots of different kinds. I'm going to use some table sugar and some sulfuric acid. Now you can see that this is dribbled and already eaten some of the label. It's 18 molar, it's kind of hard to see. That means it's really, really concentrated. Molarity is how we measure concentration. So 18 molar means 18 moles per liter. Usually you get about 1 molar or 0.1 molar with a lot of acids. So this is super strong. I'm going to get about 50 milliliters in my container. Notice I'm wearing gloves and a lab coat. I'm also wearing goggles, but you can't really see my face. So about 50 milliliters. Always, always cap it right back up. So here's my 18 molar sulfuric acid, and here's about 50 grams of sugar. So I'm just going to add these, and we're going to watch a decomposition reaction. First, I'm going to turn on the fan, so it's going to be super loud, because it's going to make some stinky fumes. Black. See, it's gone from yellow to black. It's pretty nasty stuff. Basically a sludge. It's also really warm to the touch, which tells me it's an exothermic reaction, meaning it produces heat. Even more warm, so I'm going to stop touching. I would like to interject here that I did not speed this up or do any kind of time lapse. This is the exact time frame that this reaction progresses. It produces steam that quickly, and it grows that quickly, and it gets hot very quickly as well. It's a very quick reaction and a very awesome one, if I do say so myself. Since the fume hood is very loud, it's hard to hear what I'm saying, but I'm saying that it's very solid to the touch. See, I'm lightly hitting it with the stirring rod and poking it, and you can see it's completely solid. As you can see, it's now firm to the touch. Poking it with the stirring rod, and it's not doing anything. So not only did it expand, and it got hot, and it changed color, but it also changed texture. So we have one big solid block. Also notice these are full of little air holes, kind of hard to see, but that tells me that they produce lots of bubbles, which is why it was able to expand. Because a conservation of mass, you can't end up with more than you started with, even if it looks like it. Here I grab it with the tongs. You can see it's resistant to change, but it kind of splinters a little bit. I can grab the sides and it splits in half. It breaks off easily. You can see little pieces falling out. But when I bring it closer, you can see the little air hole bubbles that it formed. It's all a solid carbon mass now. So what's happening in this reaction that makes it do what it's doing? Well, let's take a look. So here you can see we have sugar, sulfuric acid, and oxygen, which is in the air, turns into carbon, that was the solid that we observed, carbon dioxide, water vapor, and sulfur dioxide. In chemistry, you'll notice we put these little letters in parentheses, or groups of letters in parentheses. S means it's a solid, AQ means it's in an aqueous solution mixed with water, G is a gas, so we have oxygen gas mixed with an aqueous solution of sulfuric acid, and sugar, which is a solid, produces carbon, which is a solid, a gas, carbon dioxide, water vapor, which is a gas, and sulfur dioxide, also a gas. So produce one solid and lots of gases, which was the steam we saw coming off, which is part of the reason we had the fume hood on, mostly for this one. Sulfur dioxide's fun. AQ means it's an aqueous solution, means it mixed with water. If it was just water in the liquid form, we would just put an L. Now you may be looking at this and noticing there's a half for the coefficient. That's not something we normally do, but this is one of the very rare cases where you might see it. We could also balance the equation out this way, in which case we have an O2 and we have 2 of everything else. We've doubled everything else, basically. Either way it works. We just do this to kind of shorten it so we don't have to have 24 carbons, 48 hydrogens, so on and so forth. Now you couldn't smell this reaction seen on camera, but the fact that it has sulfur dioxide can give you a little hint of what it's going to smell like. It's going to smell like sulfur. It had sugar, so it kind of smells like caramelized rotten eggs. Yummy.